Hello everybody, for today we are going to talk about transformation of graph. So there are actually three types of transformation. One is actually translation, the other one is scaling, and the last one is reflection. As for translation, it's actually about having the graph shifted to the right or shifted to the left. As for scaling, it's actually making the graph wider or narrower. As for reflection, it's actually reflecting the graph in the x-axis or the y-axis. So for our what we are going to do today, the focus is actually to translate the graph up or down. Okay, so for translation, if we are given a graph, say y equal to fx minus a, or y equal to fx plus a, where a is actually greater than 0. For a greater than 0, the graph of y equal to fx minus a is actually a translation of the graph y equal to fx through minus a units in the positive direction of the y-axis. Okay, we always use the positive direction of the y-axis. We don't use the negative direction. Okay, by convention, we always use positive direction. And minus a units means that the graph is actually shifted downwards a units. Suppose we are given the graph y equal to fx plus a. The graph y equal to fx plus a is actually a translation of the graph y equal to f of x through a units in the direction of the positive, direction of the y-axis. This means that the graph is actually shifted down a units, shifted up a units upwards. Okay, so same thing, we always talk about the positive direction of the y-axis. But for this case, it's actually a units upwards. Okay, so it's like a units upwards. F of x. So what does it mean that the graph is actually translated? Okay, that means that suppose we want to draw the graph y equal to fx plus 4. It means that we actually move the graph y equal to f of x, which is this one, okay, upwards by 4 units. Suppose we want to draw the graph of y equal to fx minus 2, given the graph y equal to f of x. That means we are going to shift the graph y equal to f of x downwards by 2 units. So in the end, we shall have this graph. Okay. Now suppose there's a method of actually make use of the equation so that we can draw the graph. Suppose we want to draw the graph of y equal to fx plus 2, right, from the graph of y equal to f of x. We can actually replace y equal by y minus 2 in the equation y equal to... Sorry, this one. Okay, suppose we want to draw the graph of, say, y equal to fx plus 2 from the graph y equal to f of x. We can actually make use of equations like this to help us to see in the end what graph we will get. Suppose we start with the equation y equal to f of x, and we want to know how to draw the graph of the equation y equal to fx plus 2. What we need to do is that we actually replace the y, right, by y minus 2. So in this case, if I replace this y, okay, by y minus 2, I will get something like this. I will get y minus 2 equal to f of x. So in other words, if I bring my minus 2 over to the other side, I will have a y equal to fx plus 2. Okay, so what is the implication of this? Okay, the implication is that when we replace y by y minus 2 in the equation y equal to f of x, we are actually translating the graph y equal to f of x 2 units in the direction of the positive y-axis. That means it's 2 units upwards. Okay, some of us may have difficulty remembering whether it's 2 units upwards or 2 units downwards. So what we can do is we actually, when we replace y by y minus 2, we just let y minus 2 be equal to 0. Okay, so we just have something like this. We equate y minus 2 equal to 0. Okay, then we will get y equal to plus 2, which means that the graph is actually shifted upwards by 2 units. Okay, now suppose we want to draw the graph y equal to f of x minus 3 from the graph y equal to f of x. Okay, what we can do is we use the same method like this. So we start with the equation y equal to f of x. Okay, finally we must get to the equation y equal to fx minus 3. Okay, to do that, we can actually replace y by 1 plus 3 in the original equation, which is y equal to f of x. Then we will get this y plus 3 equal to f of x, which in turn gives us y equal to fx minus 3. So what is the implication of this? So when we replace y by y plus 3 in the original equation, we are actually translating the graph y equal to f of x minus 3 units in the direction of the positive y-axis. That means we are going to shift the graph 3 units downwards. Okay, so if you want to remember how to actually, whether the graph is shifted upwards or downwards, what we can do is, we can equate y plus 3 equal to 0. Okay, because just now we replace y by y plus 3. So if we let y plus 3 equal to 0, we will get y plus 3, y equal to minus 3. This means that the graph is actually shifted downwards by 3 units. So for the next lesson, we will be talking about graphs that are actually shifted to the right or shifted to the left. Okay.